Hey everyone, this is guided practice 26. So we are in section 7.2, looking at the solutions to trigonometric equations. We're going to jump right in here. Remember that we're solving trigonometric equations. So we are looking for the angle measure that gives us the value of that trig function. So for tangent equals -1, we're thinking what value of tangent gives us 1? Well, I can get tangent, right? This is opposite over hypotenuse for tangent, and I want those to be the same. So opposite and wide, hold on, back it up. Opposite over adjacent. So I want the opposite and the adjacent side to both be 1. Well, that happens in a 45, 45, 90. So my reference angle here is going to be 45 or pi over 4. But notice that this is negative. So I need to put that in the negative quadrants. So let's see, C-A-S-T. That means tangent is positive in A and T, right? All and tangent. And so it's going to be negative in C and S. So that means we're putting 45 degrees here. And we're putting 45 degrees here. That does not look like 45, but you get the gist of it. Let's try again. There we go. A little better. Okay, now to figure out what these angles are, we're going all the way to here, would be 180 minus 45. So that's going to give us the 135. Okay, and then convert your 135 to radians. So 135 divided by 180 and reduce your fraction. So that is 3 over 4. So our first answer is 3 pi over 4. Then we want to go all the way around to this one. And this is 45 degrees short of a full circle. So it's 30/60 minus 45. And that's going to give us 315 degrees. If I divide that by 180 to convert to radians, turn it into a fraction, I get that x equals 7 pi over 4. Okay. So if they were asking for what values from solutions from 0 to 2 pi, then this would be my answer, right? So from 0 to 2 pi. Now, if they ask for in general, then all I need to do is kind of compensate for my coterminal angle. So I'm going to add 3 pi over 4 plus 2n pi and my 7 pi over 4 plus 2n pi, right? The n, if it's negative, allows you to subtract, and when it's positive, it means you add. And remember, that's how we found our coterminal angles back in section 6.1. Okay, so we can go around as many times as long as we land on that same spot. So that's our number 1. Number 2. Okay, so when we have something other than an x sitting inside our trig function, we're going to substitute that out. So we're going to make this equal to y. So I'm going to let y equal x plus pi over 4. And that means that now I'm working with the sign of y equals 1/2. Now this is one we've done a couple of times in the various videos. 1/2, right, is going to be, this is opposite over hypotenuse. So you have a 1 here in the opposite angle and a 2 here. This comes from our 30, 60, 90, where this angle is 30. Okay, so we are going to put that where sign is positive. So let's think about where that is. So C-A-S-T. I'm going to put my 30 degrees in the two places where sign is positive. Well, sign is positive in all and in S. So we're going to put our 30 degrees over here. And we're going to put our 30 degrees over here. Okay, that first one is just plain old 30 degrees. So my x is going to be, my y, that's what I'm solving for here. So y is equal to pi over 6. That's 30 degrees. 30 over 180 is 1/6. And then we are going to get our second angle. So if we start from here and go all the way over here, you're going 180 minus 30. So 180 is going to give you 150. And if we convert 150, so you're taking 150 and dividing it by 180, that gives you 5/6 pi. So 5 pi over 6. Okay. So those are my values for y. Now I want to go back, and my y is equal to x plus pi over 4. So I'm going to plug that in. So from here, I'm going to have x plus pi over 4 equals pi over 6. And I'm going to solve x plus 4 equals 5 pi over 6. Oops. And then I'm going to solve each one of these. Okay. So all I'm going to do is I'm going to subtract pi over 4 from both sides. Get common denominators. So that's going to be 12. So that's going to be 2 pi over 12 and 3 pi over 12. It's going to give me negative pi over 12. We can leave it negative. That's not a problem. If we wanted to make it positive, we would just add 2 pi to that. So then you're adding 24. So that's going to be 23 pi over 12. And then we're going to look at the second one, and we're going to subtract pi over 4 here as well. And so we're going to get x equals 5 pi over 6, and let's minus pi over 4. Let's get common denominators again. So I'm going with 12 as my common denominator. So this is 3 pi over 4 and 10 pi, because if I multiply the bottom by 2, I've got to multiply with the top by 2. And that's going to give me 7 pi over 12. Okay, so then I have two solutions here. So x is equal to 7 pi over 12 and 23 pi over 12. Okay, now if I wanted that in general, then you're just going to add your 2n pi onto that. So x equals 7 pi over 12 plus 2n pi. X equals 23 pi over 12 plus 2n pi to compensate for our coterminal angles. Now notice that I didn't get twice as many in this case, and the reason for that is because my x is not multiplied by anything. There's just a 1 there, so I'm going to get 2 answers. The adding does not change the number of answers I get, just the number, just if I were to multiply that by something else. Okay. On to number 3. Number 3, take a look. I've got 2 cosines here, so I'm going to go ahead and factor that out. And I'll have cosine x minus 1 left. And then I have 2 things that I'm solving. So sine x equals 0 and cosine x minus 1 equals 0. Okay, so sine x equals 0. That's going to be on my corners, right? So we're working with cosine x is the first coordinate, sine x is the second coordinate on your unit circle. And so I'm looking for when the second coordinate is equal to 0. So when my height is 0, so that's those 2 points. So that's when x equals 0 and x equals pi. And then in general, that's going to be x equals 0 plus 2n pi. And notice that if I let n be 1/2 there, I actually get pi as well. So this is really just n pi, right? So I get 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, negative 2 pi. Then I'm going to go over here and solve this one. So this will be cosine x equals positive 1 if we add it over. And I'm looking for where cosine is 1. So again, that's going to be on my corners of my unit circle. So cosine is 1 only in one place, actually, right? Its cosine is 1 up here, because down here where we would normally go to balance, it's negative 1. So it's only positive 1 in one place, because remember that cosine is the first coordinate. So it's only that point up there. So this only happens when x is pi over 2 plus 2n pi. So we get 3 solutions on that one. And lastly, now we're mixing natural logs and sines. Okay, and the way that we do that is to get rid of the natural log, we're going to use the e. Remember, we took the e of both sides when we were canceling natural logs. If you have e's, you can use natural logs to cancel. Okay, so we're going to take the e of both sides. What that means is that the ln and e will cancel out, and I'll be left with sine of x on the left. And on the right, I have e to the 0, and anything to the 0 power is 1. So now I'm solving the sine of x is equal to 1. So if I take a look at my unit circle, right, whenever you have zeros and ones for sines and cosines, you're going to your unit circle. And it's cosine x and then sine x. So I'm looking for a second coordinate that's equal to 1, so a height of 1. So a height of 1 is this whole, yeah, I got to go back and fix something. Sorry, not a height of 1. Yeah, height of 1. Oof, sorry, blanking on that one. So I want that coordinate to be 1, so 0, comma 1. So that means that this happens at x equals pi over 2, and then plus 2n pi. Now I have to go back and fix something, because up here, I said that cosine was equal to 1 at pi over 2. Let's fix that. Okay, let's again look at our unit circle. And I'm looking for the first coordinate to be 1. That's not the height, that's not the y, right? That's the x. So x is equal to 1. That would be over here when my x is 1. And so that's at 0. So this is when x equals 0 plus 2n pi. So, or we can just make it 2n pi. And there we go. So we have n pi and 2n pi, but if you're already going every n pi, then 2n pi is kind of redundant. So to put these two together, we would just say that x is n times pi, because that covers both situations. And that covers all of them.